question is asked, the motor turns gear A. This is gear A with a constant angular acceleration. So this is gear A is rotating clockwise, gear B is rotating counterclockwise, and gear A has a constant acceleration, angular acceleration is constant. It starts from rest. So initially they are at rest. The cord is wrapped around the pulley D. This is a pulley D, and this block is lifted upward when the motor. This gear is linked with the motor. Behind the gear there is a motor, and this is moving clockwise rotation. Find the velocity of the cylinder C. So you have to find out the velocity. The final velocity equals to initial velocity plus acceleration of the block. Using this formula, and the distance it has traveled in 3 seconds. So you have to find out the distance using this formula, A sub C. So A sub C is related with the acceleration, linear acceleration of the block C. So this is what we have to do, but we are not given directly what is the acceleration of block C, but we have understood that the meshing point, this is the trick, the meshing point, the velocity is common, acceleration is common. So I'm going to use this formula here. So the velocity equals to omega A R A at the meshing point. Okay, this velocity equals to omega A R A omega sub B R sub B. Also, the acceleration, tangential acceleration at this point is same. Omega, not omega, but this one is alpha A R A, alpha A R A, alpha B R B. So this alpha A is 4.5. Radius of this, if we closely look, the radius is 75 millimeter. So alpha A is 4.5. R sub A is 75, equals to alpha B, which is not known, but we know that this gear, the radius of this gear is 225. So if you do the math, you can find out the angular acceleration of gear B, which is 1.5 radians per second square. And this B, when it is rotating this way, the disc or the pulley is also rigidly moving, fixed with the gear B. So alpha B is same as that of alpha D. And you know that acceleration equals to alpha B R B, alpha B R sub B equals to alpha D R sub D. And R for this gear or for this disc is 125. So can I write down this 1.5 is for this parameter, for this variable. R sub D is given 125, but I have to convert it into meters. So if you do the math here, you should get 0.1875 meters per second square. So this is the acceleration of this block C. This block C, as I mentioned, this acceleration is needed to complete these two equations. So let's apply this acceleration value here and find out what is the velocity after 3 seconds, I believe. Yes, velocity after 3 seconds. So now we have found the acceleration of the block C. Initial velocity is 0 because it is starting from rest. 0.1875 times 3 gives you the velocity of this block C, which is 0.563 upward direction meters per second. And the distance it has covered, initially it is 0, initial velocity is 0, half times 0.1875 times 3 square. And if you solve for this, you should get 0.844 meters. This covers this much distance in 3 seconds using this value.